Hi,
How are you?
I'm doing okay. I'm just like a
Okay.
little allergic right now.
Hmm? You have allergy.
Yeah, because it's like fall.
Okay. No problem. Cold winter or something.
Hmm.
Okay. First, let me see how much you have so far. Show me your UC score. Let me see where you are so far.
Oh, wait.
Are you okay so far?
Yeah, it's not that bad. I'm on 2.2B.
Primitive data. Okay.
Yeah. So I just need to like catch up by like two more sections.
Okay. Okay. No problem. I just want to roughly know where you are. Okay.
Hmm.
Okay. So now I'll review you a few things, making sure I'll ask you some question and make sure you understand it.
Hmm.
Okay, so now first question for you is, so what is available?
It's like something that you could set it's like a placeholder that like holds like value.
Okay, so that's you can check. Okay, so you may have a lot of primitive data type. So what is primitive data type?
Primitive data. I remember it's something to do with like RAM, but I forgot.
Okay, so primitive data type versus reference data type. So can you tell me what's the difference between primitive data type and reference data type?
I'm not too sure.
Okay, no problem. So primitive data type is something like integer, chars,
Hmm.
double, boolean. These are primitive data type. Okay, so primitive data type means you have a variable. Let's assume you have integer a equals 3.
Hmm.
Then you will have a memory location that's actually named a, and its memory address maybe is AA2F something. So there's some address, but you put the value of 3 right on the memory location.
Hmm.
This we call it primitive data type. Okay. So this is primitive data type. Reference data type is different. Reference data type is something like string. So that's assume that a string equals ABC. So ABC has 3 letters, or sometimes your string S equals A, B, C, D, E, F. There might be 5 letters. So this string, you declare a string as now maybe 3 letters, maybe 5 letters. So you really don't know how much memory you need to have.
Hmm.
So that you cannot use a primitive data type. You have to store it as a reference data type. So this reference data type, it creates some memory location and you store A, B, C in there. And then it can be ABC, can be A, B, C, D, E, F, depending on how long it is. And then your string will hold in the address to that memory location. So it's indirectly pointing to the data that we call it reference data. Is that okay?
Hmm.
Okay, so this one is first we talk about what is primitive data type, what is uh,
Wait,
reference data type. Hmm?
what is reference again? Oh,
Reference data type is indirectly pointing to the memory location.
oh, through like another variable.
No, it actually just remember the address. It doesn't remember the value. A, you directly put the memory 3, the data of the 3 in the memory. So
Hmm.
primitive data, you directly put the data there.
Mm-hmm.
While reference data, you put the address, maybe AAB3, and then AAB3 is right here. You actually put your ABC there. It's indirectly pointing to the data.
Oh, okay.
So that's different. Okay. Okay. These are the difference. So now in the AP level, you need to take a few data type. Okay. You have integer type, you have char type, you have double type, you have Boolean type. These are four data type that AP CSA would test. There are other type that AP don't test, but you may want to know. For integer, there are four different types. They are byte, short, integer, and long, int. Okay, let's call integer as int. So these are four different types. Char is one type. Double, there are two types. They are row type and double two type. Okay, so totally there are 8 different primitive data type. Byte, short, int, long, char, double, float, and Boolean. Okay. So the first one here is actually is integer type. So these are integers. Char is characters. So integer used to store your data of 0, 1, 2, -4. These are stored in the integers, but they are four different types. Char is used to store your letters, so your A letter, B letter, whatever. Double used to store real numbers, so it can be 3.14. Boolean used to store the Boolean value, so it can be true or false. Okay, so far okay.
Yeah.
Okay, so these are the frequency data types you need to remember. Now, although it's not tested, but do you know what's the difference between byte, short, int, and long?
Isn't it like the amount of like how much it can like store?
Yeah.
Because
So how much byte can store?
I forgot. Isn't like 8 bits or something?
Is a bit, yes. So what is a bit? What that bit really means?
Memory?
It's related to memory, but what that really bit really means?
Yeah, I'm not too sure.
Okay, it's okay. We are teaching you, right? So don't worry. So bit, let me erase everything. Okay. So bit really means binary digit.
Oh.
So binary digit means it only has a 0 or 1. 1, 0 or 1 is actually one bit. Okay. So let's assume that you have so eventually when you go into the data, you say you actually store them into the computer. It's not really storing as 0 or 1. It is storing in electronic wave, low or high voltage level. So for older system, this one may be 0 volt, this one may be 5 volt. Nowadays, they may use, say, 1.8 volt system, maybe using 1.2 volt system, okay? So the high voltage may be changing, but there will be a high voltage level, low level. So low voltage level, we call it 0. High voltage level, we call it 1.
Mhm.
So it is really an electronic format.
Mm.
Is that okay so far?
Yeah.
So this one so far, the computer we are talking about is actually electronic computer. That means it is using electricity to drive your computer. Okay. And certain days, they may be a photonic computer using light or fibers to represent the data, or some day maybe using the radio wave to represent data. Okay, so if you transmit the data through the cell phone, it actually using microwave, maybe using the so-called radio wave to represent the data. So there are certain kind of media that you store your data that we call it media. So in the computer, what the media we talk about is electricity. Is that okay?
Mhm.
And they have 0 or 1 to store the data. And every single bit, binary digit is called a bit. It's either low or high voltage, and logically we interpret it as 0 or 1. Okay, that we call it
Mhm.
bits. Now there's another term called byte. So what is a byte? So bit is a single digit. Then what is a byte? So I post quite a few of the slices, my handwriting into the group, right?
Mhm.
You can see that in Facebook. Do you see that
On Facebook?
on Facebook group? Yeah, your dad can also see it. Do you see it?
Yeah.
Okay, what's the purpose? Why am I posting it there?
For me to like memorize it.
No, after
Like,
class you should take notes.
oh yeah.
Is that okay?
Mhm.
Okay, just remind you. Okay,
Yeah.
after class, that's actually helping you to actually take notes. Okay,
Mhm.
that's why I posted there. Okay, let me clean it everything. So now we actually do know what is bit. Now the other word, what is byte?
Is it like multiple binary, like a combination of like binary options or something?
Yeah, I mean, what's the relationship of bits and bytes?
To the power of eight? Two to the power of eight. And like byte is like two or something like that.
Okay, so byte originally is BIETS because it's bits. Is that
Mm-hmm.
okay?
Yeah.
But the problem is the early days they call it bits. But because these bits, the eye actually look like it's biting something. So they don't like it, so they change the I to Y.
Byte.
Yeah, originally it's byte. It's actually bits. It's actually written in this way.
Oh, I see.
And then the people don't like it. So they said, this is not okay. So we change it to byte.
Okay.
Okay.
Yeah.
That's why we had the byte now. So how many bits a byte?
Eight.
Why?
Yeah, I don't know.
The answer is there's no reason why. This is just a custom.
Oh, it's just like a set thing.
So people use a 5, 6, 7, 8, even 9
Mm-hmm.
different bit for a byte in the early day, but somehow eventually people settle with 8. So there's no reason why 8 is big because 6, 7, 8, 9
Mm-hmm.
they all use it before. Is that okay?
Yeah.
They all use it before. So I'm trying to actually review you, okay, give you the review. So you still need to study ahead of us. Is that okay?
Yeah. Mm-hmm.
That otherwise, if I talk, you totally have no idea, then that's actually spend more time. You know what I say?
Yeah.
So that's why we only have 1 hour, but I can only review after you uh, already study. Even though I will add more material for you, but that's good for you. You know what I say?
Hmm.
You must study ahead of me. Okay. So next time, if we progress more, you have to catch up. Not only catch up my schedule, but also need to be ahead of me. Okay.
Okay.
Okay, no problem. Okay, keep that in mind. Just to remind you. So the
Hmm.
byte actually there's no special reason why 8-bit is picked, but somehow they pick 8-bit, and 8-bit originally is a 7-bit. IBM's ASCII.
Oh, ASCII too.
It's called American Standard or Standard Code for Information Exchange.
Hmm.
For information exchange. This is called ASCII. So ASCII. Okay, inter exchange. Okay, this one is not exchange, inter exchange. So this is why it is called ASCII. It's America Standard Code for Information Exchange. So what this really means is you send email. Email is information exchange.
Yeah.
So that's the code for email.
Hmm.
I send you an email, and then I'm not sending you ABCD. I'm sending you 0, 0, 1, 0, 0, 0, 0, 1. This is 4 hexadecimal 4. This one is 1. So hexadecimal 4 1. This really means A.
Hmm.
That is called ASCII. Is that okay so far?
Okay.
If I touch something that you already know, you can tell me, okay? You can tell me that, okay, this is things I already know quite well. Then we can cut short.
Mhm.
If you never heard of it, then we should continue, okay?
Yeah,
Otherwise,
I've heard
we
of
are.
ASCII before.
Okay, so this is ASCII. So ASCII is used to represent your letters, okay, your letters. But
Mm.
here, actually, ASCII, like the English letter is 8-bit, right? Now, now how about Chinese letters?
Chinese.
How Chinese letter is stored in computer?
Is it using the pinyin?
No, they don't store it as pinyin. No, they are not.
Well, I don't know.
Okay. So let's see. Your last name is Chiang. Okay. Yes, and your last name is Chiang. Okay.
Mhm.
So basically, in China, this one is called GB. It's a 国标嘛. Okay. And in Taiwan, it's called Big Five code. And actually, Big Five is before GB. Okay, because Taiwan's computer industry is actually earlier than China. Okay. But anyway, most of them are not in popular use right now. Actually, right now they use Unicode.
Unico.
Yeah, Unicode. Unicode is invented by UC Berkeley
Oh,
and later adopted by Microsoft. Okay,
yeah.
and then okay, now then this is Unicode. Okay, Unicode. So ASCII is used for English. So it actually originally ASCII is actually 8-bit. Okay, but Chinese letter is more than so 8-bit. You can store how many letters? You can store 2 to the power 8, right? Each one is 0 or 1, 0, 1, 0, 1. So totally just you can only store 256 symbols. So it's way not enough for Chinese anyway, right?
Yeah.
So then they use the Unicode. So Unicode has a few formats. Unicode has UTF-8, UTF-16, UTF-32.
What does UTF mean?
UTF is Unicode.
Oh,
So it's the 8-bit UTF. I think it's a Unicode transporter, whatever folder and something, okay?
mm,
That's a standard name. So this one just means that it's actually, you can search internet for the definition of the UTF, but it's actually just means the Unicode.
okay.
So this 8 is 8-bit, 16 is 16-bit, 32 is 32-bit, okay? So the ASCII becomes part of Unicode 8 and part of Unicode 16. For example, if you store Unicode 16, A, the capital letter A should be stored as 0x0041. 41 is the 8-bit hexadecimal base 16 number for A. We talk about it. But you put a 20 in front of it, then it will become the capital letter A in the 16-bit UTF. Is that okay?
Wait, why do you need to add two zeros?
20 means it's this 41 is only 8 bits. But you need to put two more zero in there, it
Oh,
becomes
okay.
16-bit.
Yeah, I see.
So let's make so 00, anything start with 00 are European or English letters. Is that okay?
Okay. Yeah.
And why are we talking about UTF-16? It's because UTF-16 is the core used for Java.
Oh, what?
So we talk about so much just because Java, actually also Python, they both use UTF-16. And if you use, say, if you are using HTML website, right,
Yeah.
is using UTF-8, HTML, because website mostly English, so they use the AP format.
What about UTF-32? What uses?
32 is longer, just longer.
Oh,
So longer, if you are longer, sometimes you have some later like emoji also come in. Some emoji, you know emoji?
yeah, yeah.
Emoji is the smiling face, those kind of things. Okay, let's actually look at the poll. Okay, right now you probably don't know what I'm talking about. You actually have no idea of what I'm talking about. Not a problem. Okay, don't worry. So let me bring up my project. We are talking something useful. Okay, so don't worry.
Okay.
Actually, and I try to teach you something extra that's not covered by the text or the UC Scout covered. Okay,
Mm-hmm.
making sure you understand more, you learn more.
Okay.
That's why I want you to study first. If you don't study, then I probably cannot teach you too much.
Mhm.
Then we're just repeating whatever UC Scout is, then that doesn't make sense. Okay? So you have to spend at least every week, at least every week, at least 5 to 10 hours on APCSA.
Mhm.
Okay, let's call it chapter 2. So now I create a new class that's called data. Okay, you create a project, you create a class. First, you need to remember your public static void main, okay? So you create a public static volume.
String ARGS.
Now, you do have a character that's assumed is character A. Mhm. So that's actually converted to integer A. So if you print the number A and you print the data A, let's see what happens. So char type is a UTF-16. So when you print the A as integer, that will give you 65. So this is 65 actually is base 16. Do you understand what is base 16?
It's like every like tens place is 16.
So
So
you do 65 divided by 16, you end up with 4 remainder 1. Is that okay?
mhm.
You read from here to here, then we say it's the 41 hexadecimal. Okay?
Yeah.
So that would be 0041. That would be 00000000001. So this whole thing in your computer, we call it UTF-16, is representing this A later.
hmm
Is that okay?
Yeah.
Okay. And it's also a number, so you can also convert it to an integer lowercase a, and that will print you the number 65.
Oh, I see.
Okay, so that's actually the first thing. Character store the representation of your your symbol by ASCII code. Okay, but it actually is not really ASCII code. It should be UTF-16. Okay.
Yeah.
Now let's actually look at let's assume that we actually want to look at this one. Chain. Okay, let's actually search internet. I use the traditional Chinese. Okay, so I search for the Unicode for it. Okay, so this Unicode is,
Or 8B.
yeah, you can use this one or this one. Let's use both. Okay, let's copy both.
It says 84811.
So let's put it over here. Okay, so these are two numbers you can use. You can use a single code. Let me see. You can use a single code /u each. Okay, this one is a simple by Chinese. Okay, so that's actually have another one. This one is
85323.
this is actually traditional Chinese. Okay, so these two letters are treated as different letters. It's written in different ways, so actually they are treated as two separate letters in Unicode. Okay, is that okay?
Yeah.
Okay, it's too late already. But not only that, actually, this is not only that, but they actually do. So the poker symbol,
That's for like special like icons.
yeah, but it still is Unicode.
Yeah.
So you go back to here. Now this one is called chart state. So you can use a backslash U inside the code or Unicode. You can also use 0x. 0x means base 16 number. So
Oh,
you can use a Unicode or use a base 16 number. Both are working.
okay.
So this it will be a spade. Okay, it will be spade. I just want to show you how this different kind of symbol being represented in the computer system. Okay.
Mhm.
Okay, so you got a spade. Now talk about emoji, so you can actually do emoji um, form. Then you can search for emoji form, okay? And there's different symbols. So each one of the symbol they do have a Unicode. Is that okay?
Mhm.
But that's too much for us, okay? So I'm not going to explore it, okay? You just know that there are more later that you can handle, okay? Anyway, these are symbols. So symbol, we sometimes also talk about it as text story in computer in this way. Now we go back to numbers. So number, we have integer, char, short. We go back to numbers. So now the question is, if I have integer a equals 3, so what, okay, how does integer being represented in computer? So we talk about chart. Chart is a symbol for A, B, C, D. Now I'm talking about number. So how will number integer being stored in computer?
Isn't it also in terms of bits?
It's in terms of bit, yeah, but how?
Uh, they change it to binary.
You change it to binary, yeah, that's correct. Okay, so first one is using binary, right? But how about -2?
-2.
Hmm.
Hmm.
So let's actually use the binary number. So let's assume that you have 4 bit. So 4 bit, you can store your number as maybe 0000. This one for 0 for sure, right? No problem. So 1 would be 0001, right? Two
Yeah.
would be 0010, right? Continue.
Mhm.
So what is the maximum number that you can store in 4 bit?
4 to the power of it's it's 2 to the power of 4 -1.
So it would be 15. So your 15 is 1111,
Yeah.
right?
Hmm.
But these are purely positive. Then how can I store -1 or -2?
Mm,
There's a question, right?
yeah.
Okay, we will answer it later. So first one, you need to know about the computer store data in the binary format. Okay, now before we go into the so-called negative number, let's focus on positive. Okay. First thing is that how to convert the 57 to binary.
You divide by 2, then you count the remainders backwards.
So you do have 57, and then what you do?
Divided by 2,
Divide by 2. What do you get?
um, 28. Remainder of 1.
And then
Then you divide 28 again.
what do you get?
14.
Remainder 0. And then,
You divide it again.
okay. So basically, we do this. We start with 57. You divide by 2, right like this, okay?
Mm-hmm.
So you have 28 remainder 1. Divide by 2, you do 14 remainder 0.
Mm-hmm.
Divide by 2, you get 7 remainder 0.
Mm-hmm.
Divide by 2, you get 3 remainder 1. Divide by 2, you get 1 remainder 1. 1 cannot be further divided, and you read from here to here, you become 1, 1, 1, 0, 0, 1.
Mm-hmm. Yeah.
That will be your binary number, okay? Okay, so this is converting decimal to binary.
Mhm.
Okay, now how to convert the binary back to decimal? So we do have this one, 1110001. We want to convert it back to 57. How can I do it?
Most of the times I just like read it, but I'm not too sure how to like do that.
You need to learn it.
I just read it, to be
Yeah, I
honest.
know, but you need to learn it before for computer science. You have to do it. So
Um,
if I given you this problem, how are you going to solve?
um, since there's like 5, I just change it into 1 0 0 0 0 0 plus 1 0 0 0 0 plus 1 0 0 0 0 plus 1.
No, that doesn't work. I need you to convert it to decimal value. So first thing you need to know about this is the so-called number system. So a number system, you do have a place and value. So this place is 1, or you can do the place as 2 to the power 0. This place is 2 to the power 1. This place is 2 to the power 2. This
Yeah,
place is 2 to the power 3. This place is 2 to the power 4. This place 2 to the power 5. So 57 really is 1 times 2 to the power 5
yeah, I was
plus
trying to,
1 times 2 to the power 4 plus 1 times 2 to the power 3 plus 0 times 2 to the power 2 plus 0 times 2 to the power 1 plus 1 times 2 to the power 0. Okay, that's actually the original
I
uh,
was going to.
present value. You have to tell me this because I'm asking you how to convert it to the
I usually like separate.
decimal value.
I separated it first, and I was gonna multiply it by the power of that.
No, that's still not the right way.
It gets the same answer though.
You get a same answer, but it will take longer time. So usually we don't do it in this way. We actually do this. You put right here, you put 1 here, put 2 here, put 4 here, put 8 here, put 16 here, put 32 here. You time it. So this one will be 32 plus 16 plus 8
Yeah.
plus 1. And this you will get 57.
Yeah.
When we actually list down the value, we do this kind of long multiplication table.
Can't you do that for any base as well?
Yeah,
You just write out like how many there are, and you just do it to like the base that you want it to, and you to the power.
yes, yes. Okay, so this one is, you need to know about base. So we talk about base 10 converted to base 2. That's converting to binary. And also base 2 converting back to decimal. How about now, if we do base 10 converted to base 8.
Base 8.
So then now I have 57. What should I do?
Can you divide it by 8 and get the same thing?
You get what?
7.
And then
78.
hmm?
78.
Wrong.
Wait, what else could you do?
You have 7 remaining ones, so it actually is 71.
Oh, wait. Oh, shoot. Yeah.
Okay, so this one is base 10 to base 8. Now, next one, if you do have base 10 converted to base 16, this time let's try 79. What will you get?
Can you do the same thing with this? 16?
Tell me the value.
Wait.
So you'll be 4
It's, yeah, 4. And this is
remaining.
15, I think.
Hmm?
15.
So what would be US base 16 value?
B, C, D, E, F.
So
4.
it's a 4F, yes. So you need to remember 0 to 15's hexadecimal code, okay?
Yeah.
That is something, I just review you, okay? Make sure you understand. Know that you know something, okay?
Hmm.
But you have to be quick. Since you are studying computer science, you need to be quick.
Yeah.
Okay, whatever. So when we calculate the ages or we calculate the color conversion, we need a lot of these. Okay, I just review you this different number. Now we go back to the problem of how the negative number being represented. So I'm going to show you the slices that show you the where the negative number is. So you don't have not many, you don't have negative number in our number system. Actually, we don't. We only have the positive numbers. So basically right here, we do have this decimal to binary. You can download the slices, okay? Or this one for conversion from uh, binary back to decimal. And these tables you need to remember. Okay, this
Mhm.
difference you need to remember. Now, next one, you need to remember the range of the different integer values, the range.
Yeah.
Okay, roughly you need to know about this different range. So byte is shorter than short. Shorter is 16 bit. And short and char, these two, they are slightly different. Short is 16 bit with a sign plus minus. Char is unsigned, it's only positive. So only positive used for laters, but sometimes this later can also be considered as numbers. Okay,
Okay.
so that you need to know. Now this one you actually 32-bit 32-bit integer, 64-bit long integer. Okay. And then you have the floor and bubble for 32-bit and 64-bit. So
Wait,
these are different.
what's a floating point?
We'll talk about it later. Okay. You're supposed to study it before. Okay. You
Oh,
are supposed to know this before. But I know you don't understand, but we will talk about it later.
okay.
And you are supposed to know it because you go through the whole solo learn. If you don't rush, you should pick up something. Okay.
Hmm.
You rush yourself actually going too fast. So that would have some drawback that you later may forget something. Okay, anyway, right here we do have 4-bit number system. So it's from 00 to 1111. So we try to represent the number using two's complement format. So suppose if you do only positive, it's 000 to 1111, it represents from 0 to 15.
Yeah.
But we want to use it for negative numbers, so we want to cut it in half. Half positive, half for negative. So this if your number with the leading one, it is considered to be negative. But it's not just number signs. No, it's not number sign. It's actually called two's complement. So how does a two's complement work is like, okay,
When it starts with a one, it's negative.
so let's assume that you have five. So your five is 0, 101. This is number for five. So we will use using the 4-bit system, we will use a 2 to the power 4 minus 5 as minus 5. So this number is 16 minus 5. It will be 11. 11 will be 1011. So when you sum these two numbers together, 1 plus 1, you get 0, carry 1. 1 plus 1, you get 0, carry 1. 1 plus 1, you get 0, carry 1. 1 plus 1, you get 0, you carry 1 to the next digit. But since you are using 4-bit system, so this 1 bit for overflow can be ignored. Then your 5 minus 5 is actually 5 plus 11. You become 16, but actually it look like the last 4 digit is 5 minus 5. It actually becomes 0.
Hmm.
So we say 5, we presented this, minus 5, we represented as this. So your minus 5 is represented as 2 to the power 4 minus 5. This we call it two's complete number. Is that okay?
Yeah.
So let's assume that we also use this 4-bit system, and now I have a number of 3. How could I represent my minus 3?
And don't you just do the same thing where you like
What is the same thing? Tell me how to do it.
2 to the power of 4 minus 3?
That would be,
That'd be 13.
and then how to put it in binary.
1. I'll give you 1. So you have 1, 0, 1, 1. I'm not sure.
You have to do it quick. Okay, so it's 1101.
Mm-hmm.
Anyway,
Shoot.
you sum these two things together, you get 0 carry 1, 0 carry 1, 0 carry 1, 0 carry 1, and you get the same thing. You end up to be 0 on the last 4 digits, but you have overflow 1 bit.
Yeah.
So that's, we call it two's complement.
Mm-hmm.
Okay, now, but that's actually not really that quick to find the number. So when I say 5, how could is actually 0, 1, 0, 1? How could you quickly find your -5? That's the problem. Okay, that's the problem. So instead of using the division method to find it, this is not quick. We do have a way to find it. It's called one's complement and then +1 to get a two's complement. So what is one's complement? So we do have minus x that actually is represented to be 2 to the power 4. Okay, using 4-bit system. Right here is 8-bit, but we use 4-bit minus x. It should be 2 to the power 4 minus 1 minus x plus 1. So this whole thing is your 1, 1, 1, 1 minus x plus 1. So let's see what is 1, 1, 1, 1 plus minus 5, 1. So you have 1, 1, 1, 1 minus your x, let's assume it's 5. 5 is 0, 1, 0, 1. So you actually minus this, you got 0, you got 1, you got 0, you got 1. And then this is actually this plus 1,
Oh,
you got 1, 0, 1, 1. This is your 11, and that is your -5.
okay, I see.
This we call it two's complement to find your method. So this one from here to here, from here to here, what do you see?
What?
What's your one's complement from here to here? What do you see?
Oh, it's completely the opposite.
This is called bifid. So two's complement is bifid plus 1.
Oh, oh, okay.
Okay,
Yeah.
one more time. Let's do it one more time with different value. Now, let's assume that you actually have 3. 3 is 1, 0. I'm sorry, 0, 0, 1, 1. You flip, you got 1, 1, 0, 0 plus 1, you got 1, 1, 0, 1. This one is your -3.
Oh, I see.
It's your 13. So let's assume that this is okay. Let's assume this is a 4-bit system. Let's assume that you do have an 8-bit system and you have 57. So let's assume you have 1, 1, 1, 0, 0, 1. As you have, this is 57. So your minus 57 in 8-bit system will be 1, 1, 0, 0, 0, 1, 1, 0. Flip plus 1, it will be 1, 1, 0, 0, 0, 1, 1, 1. This is minus 57.
Mhm.
Got it?
Yeah.
So what we trying to tell you is these are the numbers stored in the computer. when you declare it as int or byte or short or long. It's just a number of bits. You may have 8-bit system, you may have 16-bit system, you may have 32-bit system, different system, but they all use a two's complement to represent negative numbers. Is that okay so far?
Yeah.
Okay. Now let's go back to the computer. You need to speed up, okay? Right now, if you keep this is slow, you cannot catch up. So we do have integer a equals 3. Then you may have integer b equals 0, b 0, 0, 1, 0, 1, 0, 1, 1, 0. So what does this mean?
I don't know what that means.
Hmm?
I'm not sure.
You have to study ahead. That's the part you need to study ahead. That means you haven't touched this part. This one is the binary representation. You store this b is a number, is binary, it's actually 0, 1, 0, 1, 0, 1, 1, 0. In the middle, you put an underline, that's fine. Okay, you can put the underline at any location. So you put right here again, you put right here. It's actually all okay.
Mhm.
Okay. But usually we use a three digit or 4 digit to make sure you understand it. So this is binary representation. You may also have a number that actually 0x 4x. This one is hexadecimal. Okay.
Mhm.
Okay, so these are different integers. Now let's go back to here. Let's talk about, I'm going to, we touch the ones complement, these differences. Next one, the thing that I just talk about is this literal type. So when you study the UC Scout, you should also go back to download the material we have, okay?
Okay.
Otherwise, you may not catch up. Okay, this one, that's actually character set, we talked about it already, the chart and the ASCII code, and we actually covered it already. Next one, what we will cover is the 14-point numbers. So they are numbers that is whole numbers. So you do have integers, short, long, double. I'm sorry, long. Okay, those are integers. So integer use a positive number like 0, 1, 2, 3, 4, 5 that we know. Negative number we use a two's complement, so we know that. Now this one is the real numbers. If you have rational numbers, then it's stored as floating point format. It's different from the integer. So you do have two types of a variable. One is double, one is float. So float is 32-bit, double is 64-bit. So let's pick the float. So for a 32-bit, it will be a sine bit and the 8-bit of the exponent bit and Mantissa bit 33-bit.
What
So
is
what does this mean? This means that if you want to represent a 1.0 So your sign bit will be 0. So right here this is 1, right? Times this one is 0, so 1.0. So this Mantis part is 0. So you will have 23 bit of the 0 right here. So here you have a 0 right here. And your exponent is e minus 127. So again, this number should be 0. So your e need to be stored as 127. So it's 0, 1, 1, 1, 1, 1, 1, 1. So this number 0, 0, 1, 1, 1, 1, 1, 1, 1, 0, and again, totally 23 zeros. This whole thing represent 1.0. Is that okay?
I don't understand the Mantis part.
Mental such as the fractional part. You got 1 point m. Right now, m is 0. You get the all zeros.
Okay.
Let's assume that right now, if you want to store 2.0, so your 2.0 is your minus 1 raised to the power 0, that's a positive, right? So this one side bit only positive and negative times 1.0 times 2 to the power 1, right?
Mm-hmm.
So the Mentisar part is the same. It's still 23 bit of the zeros, but your power part is 1 instead of 127. So it will be 128 minus 127. So here you would store 1, 0, 0, 0, 0, 0, 0, 0. So that is your 2.0. It's a 0, 1, 0, 0, 0, 0, 0, 0, and 23 bit of the 0 right here.
23 bits.
This is called floating point numbers.
Wait, where did
Okay,
you get 128 for the exponent from?
it's from here. This is the formula, the number being represented.
Wait, but where'd you get 128 from?
128 because you need to have the 1.0 times 2 to the power 1 if you want to have 2.0.
Okay. So you just say it's 128?
Yeah,
Okay.
okay, so this is the floating point format. And then double means it's longer. Double just means it's longer. But in the AP exam, we don't test the flow. We test only double. So every time your real number, we store it as the double type.
Mm-hmm.
Okay?
Yeah.
Okay, this part, I think that's what we will cover today. Next one is that you need to learn how to write a program. So let's assume that you want to write a computing of the area. So you have radius, area, and then you try to compute it. So you declare a radius and area, and then you actually calculate the area, pi r squared,
Mm-hmm.
and you represent your data. Okay. Okay, let's write a program. So you declare your double radius. Okay, and you declare your area, double area equals radius and radius. 3.14159. Okay. Then you can print out, extend that out the print on your the area of a circle with radius of plus radius plus is plus area. Then this one will compute the area of a circle and then print it out. Is that okay?
Yeah.
One thing that you need to remember is this one, you do have some of the numbers here. It will merge with the string as a string.
Yeah.
Okay, that's something you need to know. You will merge with the string as a string. Same for this area. So this one, your 4.0 will be put over here. Then the area of 50 something will be put here.
Mhm.
And you will print out the whole thing. Okay. This
Yeah.
one is to calculate the area. So you need to understand the program structures. Okay, that's actually this program area. This we call it IPO, input processing and output. Okay, you get input processing and output. Okay, this one, if we want to get the data from outside. So same for this program. You need to use that's called circle. I think in the solo you do have this, so you need to import the Java the UTIL schema. Okay, but before you actually read in the data, you need to declare the schema.
Scanner SC equals to new scanner system.in.
So what is the system.in?
Is that how they take the input?
From where?
An interface. I don't know.
System.in means your people.
Oh.
So what is system.out?
It's
So
showing on your screen.
this is your keyboard. This is your screen. So this one will print to your screen. Okay.
Yeah.
So you print to your screen with enter the radius. Then you say your double radius equals input. Next double. You bring in a double value.
Mm-hmm.
Then you calculate the area. Let's copy from. Okay. I just want to show you the input part. These are the same, so let's copy. Okay, so this one you get the input. The input is from keyboard instead of your pre-stored value. Okay, previous one is pre-stored value. This one is from your keyboard input. So you put that input and okay. Okay, so we finish this chapter 2. You need to move a little bit faster, okay? But now these are simple and we don't want to waste too much time here. So you still not you need to move up faster, okay?
Okay.
Okay. Any question so far?
No.
No. Good night then. Bye bye.
Okay, bye.